Welcome back. This is Lesson 7, where we round out the picture we started in Lesson 6. LO6 gave you Lua and OpenResty. Today we add the other two paths for extending NGINX, NJS, which is JavaScript running inside the NGINX process, and dynamic modules, pre-compiled, so files you load at runtime. Together that's 3 orthogonal options, and the rule across all of them stays the same. Pick by use case and team, not by preference. Here's the mental model for today. 4 pieces grouped into 2 complementary paths. NJS is for custom logic your team writes in JavaScript. JS-set binds a variable to a JS function. JS-content gives you a full handler, mirroring the Lua hooks you already know. Dynamic modules are the opposite philosophy, pre-compiled C, off-the-shelf, dropped in via load module. GOIP2 is the poster child. 50 lines of Lua become a single directive and a free variable. Custom logic versus standard features. That's the split. Now extend that split into 3 paths and rate them on what actually matters in production. Lua wins on raw performance and flexibility. Lua JIT native, anything goes, but you pay an install effort and Lua syntax for a JS-heavy team. NJS trades performance for ergonomics, interpreted slower, but a single package and JavaScript your team already reads. Dynamic modules are C-native and config-only, unbeatable when the feature exists, useless when it doesn't. The decision rule stays the same. Complex custom logic goes to Lua, JS team custom logic to NJS, standard features to a module. Pick by the job, not the preference. So let's see what NJS actually looks like in practice. 3 steps, end to end. Install the package and load the .so at the top of nginx.conf, write a single .js file exporting your functions, then bind those functions back into the HTTP block. 2 binding styles cover almost everything. JRSet turns a function into an NGINX variable like upper UA, and JS.content turns one into a full request handler. 1 file, 2 hooks, and you're running JavaScript inside the request path. Now shift to the 3rd path, dynamic modules. These are pre-compiled, so files, shared libraries that NGINX loads at startup, each one adding new directives to the configuration vocabulary. The workflow is genuinely boring in the best way. Apt search to see what's on offer, apt install to drop the .so onto disk, then a single load module line at the very top of nginx.conf, above the events block. Test, reload, and you've extended NGINX without ever touching a compiler. GOIP2 is the canonical example of why dynamic modules earn their keep. You point one GOIP2 directive at the maxmine database, and from that moment, GOIP2 country code is a first-class variable everywhere, usable in maps for routing EU traffic to EU backends, inif blocks to return 451 for restricted jurisdictions, in log format to tag every request with its origin. Country-aware routing in 3 lines of config. The Lua equivalent is 50+ lines and a library to maintain. When a module exists, use the module. And in the real world, you don't choose one. You run all 3 side by side. Look at this config. GOIP2 and headers more loaded as modules at startup, an NJS file imported for scripted endpoints, and inside a single location block, Lua handles JWT verification, while the headers more module stamps the country header from a GOIP2 variable. Each tool is doing what it's best at. The decision frame stays the same one we've carried since Lesson 6. Pick the path per problem, not per team preference. So let's distill that into 3 principles you can actually carry into design reviews. First, if a standard feature already exists as a module, GOIP, Brotli, image filter, headers more, use it. Re-implementing battle-tested C in Lua is wasted effort. Second, custom business logic genuinely needs code, and the choice between Lua and NJS is a team skill question, not a technical one. Third, composition wins. The most reflexive mistake teams make is reaching for Lua when a module would be 5 times simpler. With those principles in mind, here's the cheat sheet worth printing. The top block is NJS. Load module pulls in the .so at startup, then JS import wires up your JavaScript file, and from there you've got JS set to back an NGINX variable with a function, or JS content to take over the entire request. Below that are the 3 modules you'll reach for most. GOIP2 for location lookups. Headers, more when add headers quirks bite you, and Brotli for compression that genuinely beats gzip. And remember, before you write Lua, run apt search NGINX module. Most distros package dozens of these. Time to put it on the wire. 3 drills, all using packaged modules. No compilation, just apt install. Exercise 1 is your NJS Hello World, a JSON debug endpoint that echoes back the request object, so you actually feel what the R object exposes. Exercise 2 wires up GOIP2 for country routing, with the X forwarded for trick to simulate foreign traffic. Exercise 3 is headers more. Always set security headers and erasing the leaked server and X powered by lines. Budget about 70 minutes. By the end, your NGINX looks production-shaped. Before we wrap, let's talk about the failure modes, 5 mistakes that show up again and again in real configs. The pattern is the same every time. Someone reached for code when configuration would have done the job, or reached for a custom build when a packaged module already existed. Writing GOIP in Lua when GOIP2 module is 3 lines. Picking NJS for a hot path where Lua JIT is 5 to 10 times faster. Forgetting load module after install and chasing an unknown directive error. Putting load module inside HTTP or server instead of top level, and compiling from source to add one feature, then owning that build forever. The skill, and this is the whole lesson, is recognizing the right path before you write code. So here's the whole lesson in one line: 3 paths picked by problem, not by preference. NJS gives you JavaScript hooks for request time logic. Dynamic modules are pre-compiled, so files you load at startup. GOIP2 is the canonical example, country routing without a single line of code. And the real skill is composing all 3 when the problem demands it. Next up is Lesson 08, mTLS, where we move from extending NGINX to authenticating clients at the transport layer with certificates instead of passwords. See you there.